Hi everyone. You're welcome to our lesson number 63. My name is Professor Robert, and in today's lesson, we will practice more examples of rationalizing the denominator of a radical expression. Let's start with the first example as shown. Root 2 plus 2 divided by root 2 minus 2. And we are supposed to rationalize the denominator. In other words, getting rid of the root signs in the denominator. And like in our previous lesson, we are supposed to multiply the denominator by conjugate binomials or a radical conjugate. So in this case, we have to multiply the denominator by its conjugate, and that will be root 2 plus 2. And also multiply the top by the same conjugate, because what you do to one part of a fraction, you must do to the other. So there we go. So our expression then becomes, again, by multiplying through or distributing through or using the distributive rule. Root 2 multiplied by root 2 here will give us 2. And then root 2 multiplied by 2 will give us positive 2 root 2. And then 2 here multiplied by root 2 will give us positive 2 root 2. And then 2 times 2 here will give us 4. And this is all over root 2 multiplied by root 2 here, which will give us 2. Then root 2 multiplied by 2 will give us positive 2 root 2. And then negative 2 by root 2 will give us minus 2 root 2. And then minus 2 by 2 will give us negative 4. So we can simplify the top by saying 2 plus 4 will give us 6, and then plus 2 root 2 plus 2 root 2 will give us plus 4 root 2. And this is all divided by positive 2 root 2 minus 2 root 2 will cancel out, and then 2 minus 4 will give us minus 2. And clearly from here you can see that this can cancel to negative 1 and this can cancel to 3. And so our final expression here becomes minus, open brackets, 3 plus 4 root 2. And that becomes our final answer. All right? Okay, now let's try a second example. Let's suppose we have root 2x plus 1, and this is being divided by root 2x minus 1. Again, if we are supposed to rationalize the denominator, we have to multiply the denominator by its conjugate. And what you do to one part of a fraction, you must do to the other. So even the numerator must be multiplied by the same conjugate. So that means this expression of ours at the bottom in the denominator must be multiplied by its conjugate. And that's root 2x plus 1. And what you do to one part of any of a fraction, you must do exactly the same thing to the other. So we also multiply the top by 2x, root 2x plus 1. And then like we did in the first example, we start distributing our elements by multiplying out these two expressions. So root 2x times root 2x will give us 2x. Then root 2x times 1 will give us plus root 2x. And then 1 times root 2x will give us another just root 2x. And then 1 times 1 will give us positive 1. And this is all over root 2x times root 2x will give us 2x. Then root 2x times 1 will give us plus root 2x. And then negative 1 times root 2 will give us negative root 2x. And then negative 1 times 1 will give us negative 1. So now this expression can be simplified by looking at these two. They are the same. Root 2x plus root 2x will give us 2 root 2x. So then we have here 2x at the beginning, and then plus 2 root 2x plus 1. It can't get any simpler than that because all the terms are different. They're not like terms. Then in the denominator, positive root 2x minus 2 root x will cancel out. And we are left with 2x minus 1. 2x minus 1. And then that becomes our final answer. All right? Now, with mathematics, it's key to keep working out and practicing more and more examples if you're going to master it. We don't cram, we don't memorize anything, but we just do practicing. All right? Okay, if this lesson helped you, don't forget to like, share with anyone you think needs it, and please subscribe for more algebra made simple, and see you in the next lesson. Bye for now.